Right, let's have a look at the logarithms. So logarithmic function. So the logarithm of a number to a given base is the index of the power to which the base must be raised in order to equal the given number. There you go. There's a fancy definition for you. What on earth does it mean? Okay. So if some number we know is a to the power of x, basically the opposite of an index is a logarithm. So to undo the index, if we want to find what x is, we log both sides. And so we can end up saying, well, x will equal the logarithm of that number, and the base is also a. So the bases stay the same. So if we want to solve an exponential equation or something like that, we log both sides. Where logarithms were useful, certainly before we had calculators, is it allows us to do multiplications by turning multiplications into additions. Actually, remember with indices, when you multiply, you add the powers. And so that was the basic idea behind it, because of course it's a lot easier to add numbers together than it is to multiply numbers together. So if x is the log of 1000 base 10, basically we're saying 10 to the power, because the base doesn't change, so we're saying 10 to the power of what gives us 1000. So we can turn it back into an exponential equation by undoing the log, if you like. So to undo the log, we exponentialize both sides. But as I say, the base doesn't change. So 10 to the power of x will equal 1000, and well, 10 cubes 1000. So x would be 3. So this one, 5 to the power of what gives us 1 on 25. That's what we're basically saying. Well, that would be 5 to the negative 2. So x is negative 2 for that one. Now this one, because the base is what we're trying to find, so this one is saying x squared is 64. So that's basically saying x squared is 64. So x is 8. We have positive bases. We don't usually have negative bases when we talk about logs. So yes, it is true that negative 8 squared is also 64. But when we're talking about logs, the bases are always positive numbers. So this one then is saying 6 squared is equal to what? So x is 6 squared, so x is 36. So we have some laws that allow us to manipulate logs. And the first one's a very basic one. It's basically saying that logs and exponentials cancel each other out. So if it's the base there of the exponential is a, but the base of the log is also a, they would cancel to give us the power, which is x. So log a, base a, the x cancels. And the reverse of that, if we have a to the power of log base a, they will also cancel, because the logs and the exponentials are inverses of each other. They will cancel each other out. So logs and exponentials are inverse functions. Okay, log of 1 is always equal to 0. Okay, because if we were to rewrite that one, we're basically saying a to the power of 0 is 1, and we know that. Log a base a will always be 1. Again, because, well, if we rewrite that one, we get a to the power of 1 is equal to a. So log of a base a is always 1. Then the rule that allows us to turn, as I say, a multiplication into an addition. Log of x plus log of y is log of xy. The bases have to stay the same, because it's coming from our index law about the multiply, we add the powers. So the bases should be the same. So log of x base a minus the log of y base a should be the log of x over y base a. And that comes from our division. This one's very handy when we're solving exponential equations, where we can bring the power to the front, basically. And that comes from the idea that, okay, when we have a to the power of x, and we raise that all to the power of p, we multiply the p and the x together. That's where this one comes from, that log law. All right, let's play with them. So if I've got log 20 base 10 plus log 5 base 10, well, the bases are the same. So that turns into log 100 base 10. So we're saying 10 to the power of what is equal to 100? Well, 10 squared is equal to 100. Log of 18 minus log of 9 we can turn that into a division. We get log 2 base 2, but then we had a rule that said, log a base a, that's always equal to 1. So log 2 base 2, that's 1. If we have several, all we have to remember is the plus is multiply, the minus is divide. So this is the log of 9 times 8 divided by 6 squared, because I can move that 2 to the power there. So 9 times 8 divided by 6 squared is 2. So 4 to the power of what is equal to 2? Well, the square root of 4 is 2, so 4 to the power of a half. Right, they've told me log 2 is 0.3010, approximately, and 3 is 0.4771. We have to work out the log of 27. So the question is, how do we get 27, but we're just using the numbers 2 and 3? Well, 27 is 3 cubed. So I could turn that into 3 log 3, and we've been told what log 3 is, so I can substitute in for that and get our answer of 1.4313. Square root of 2, well, that I could rewrite as 2 to the power of a half. So that becomes, that's a half log 2. Man. So a half of 0.3010, 0.1505. Log of 12. So how do I get 12 out of 3 and 2? Well, 12 is 4 times 3. 4 I could rewrite as 2 squared. So I get log of 3 plus 2 log 2, and then I can substitute in the known values for those. Now, if you want to check, of course, remember we're saying 10 to the power of what is 27. So if we go 10 to the power of 1.4313, it won't be exactly 27 because it's an approximation, but it should be pretty close. Same with the next one. I could have gone 10 to the power of 0.1505. I should get close to the square root of 2. And now last one there, 10 to the power of 1.0791 should be pretty close to 12. Alrighty. So 8, C and D is playing with the log